Okie dokie artichokes, we are doing 9.4. This section is just kind of a smattering together of the last 3 sections in a row. So it's nothing new, it's just all kind of combined together. So we're going to talk about factoring a polynomial with a GCF. And what does this stand for again? Greatest common factor. So this was the last section. This was 9.3. They said, hey, here is a polynomial, factor it. So what they wanted us to do is find the binomials that we had multiplied together in the first place to get it. And we talked about how you have to look at this last number, in this case it's 70, and list out factors of 70. So I could say, all right, I have 1 times 70, I have 2 times 35. But I'm going to jump ahead. I see that it's 17, and I can tell pretty quickly that that means it's going to be 7 times 10. So sure enough, this 7 times 10, when you add them together, gives you 17. So my factors are x plus 7 and x plus 10. And then we talked about how do you check your answer? Well, if you wanted to, you would multiply it back out. You would use your box method, and you would make sure that the polynomial that you get is this one back up here. So in this section, they show us polynomials that look like this. So what makes this one different? Well, first of all, there's a number out front, right? There's a 2 out front. And I actually noticed that not only does this one have a 2 out front, but every single one of these can be divided by 2. So there's actually a common factor in these terms. We haven't seen that yet, but I could pull out a 2 from every single one of these terms. I could undistribute a 2. So that's what I'm going to do first. So I'm going to pull this 2 out front. And now I'm going to ask, well, what did each of these terms look like before it got multiplied by 2? So I'm basically dividing each one by 2. So this one was just x squared. This one, well, what's 34x divided by 2? That's going to be 17x. And this one, what's 140 divided by 2? That's 70. All right, so now I'm not done yet. All I did was the first step, really. So this 2 now needs to hang out front. But what I'm going to do is I'm now going to turn this polynomial into a factored version. I'm going to turn it into 2 binomials multiplied together, which I already did on the last slide, right? I said that this x squared plus 17x plus 70 equals this x plus 7 times x plus 10. So I'm not going to do all that work again. I know that it was x plus 7 times x plus 10. Okay, so this is our answer this time. So we have 4 examples to write down and view together. All right, so do we have a greatest common factor here? Is there something we could pull out of every term? Yeah, I see that we can divide each of these terms by 5. So that's exactly how I'm going to start. I'm going to pull out a 5 from each term. All right, so this one, what is my 5k squared divided by 5? Well, it's just going to be k squared. Plus, okay, 35k. If I pull out a 5, I get 7k. Bring down your minus sign. And this one, if I pull out a 5, what's 150 divided by 5? That's just going to be 30. Use your calculator if you need to. What's 150 divided by 5? All right. Now, am I done? No, I started, but now I need to go ahead and factor the thing that I have inside parentheses. So I'm not done yet. Now I need to go back and factor this thing that I had inside the parentheses. Okay, so to check my answer, I am actually going to go ahead and do that. So I moved it up there. So the first thing I'm going to do is I'm going to multiply these guys back out, and I'm going to do that using my box method. All right, so sure enough, that gives me k squared. 10k minus 3k is 7k. And then I have that minus 30. Now what I'm going to do is I'm going to drop that 5 down, and I'm going to distribute that 5. Minus 150. All right, good. We get the original polynomial back. So that means that this answer in blue was the correct answer. That's how we check our answer. We multiply it all back out. So for number 2, take a look at it. Is there a common factor that we can factor out? Yeah, this time there's a 3. So I could divide each of these terms by 3. Notice they do not all have x's in them, so I cannot factor out any x's as well. So I'm going to start out with the 3. All right, so what do I do now? Well, I'm going to look at this polynomial and I'm going to factor it. I'm just going to ignore that 3, pretend it's not there. So I'm looking at factors of -6 that add up to be -5. So I know that one needs to be positive, one needs to be negative. It could be 1 times -6. It could be -6 times 1. And I'm going to stop right there because I see that this top one is right. 1 plus -6 gives me -5. So this 3 is still hanging out front, doesn't do anything. But then this polynomial changes. And factors are +1 and -6. So it's x plus 1 and x minus 6. And here is my answer. So example 3, do we have a common factor here that we can pull out? Take a look at each term. So there are no common factors with the coefficients, right? Because there's not a number on this one. But I do see a different kind of common factor. I see that they all have a lot of x's. What's the most x's that they have in common? I'm looking at this one right here. This one has 5 x's. They all have at least 5 x's. So what I'm going to do is I'm going to pull out an x to the 5th. So how many x's will I have left in this one? Just 2. It'll just be x squared. That -8 doesn't change at all. How many x's will we have left on this one? Just 1. That +12 doesn't change. And how many x's do we have left here? None, actually, because I pulled out all of the x to the 5th. So that's just going to be 12. All right, so now what do we do? Well, we're going to ignore this x to the 5th, and we're just going to factor this polynomial. So I'm looking for factors of +12. Then when I add them up, give me -8. So I know it's no use to sit here and say 3 times 4, because 3 and 4 are never going to add up to be -8. I need both of my factors to be negative. So I could do -1 times -12. No, I could do -2 times -6. There we go. Those are our factors. Okay, so this x to the 5th just hangs out front. And then this polynomial changes to these factors. All right, and there is our final answer. Okay, so I moved my answer up here just so that I have a little bit more room. Now what I'm going to do is I'm going to check my answer. So I'm going to start out by multiplying these two together. All right, and then I'm going to go ahead and I'm going to distribute this x to the 5th to each of these terms. And good, we got this original polynomial. So that means that this answer was right. Last one, we have to factor this polynomial. Do you see a common factor that we can pull out of each term? This one actually doesn't have any. There's nothing we can pull out. There's no coefficients out front, and they don't have a variable in common. So I'm going to look at my -42. Factors of -42, well, I see right away that it's going to be 7 and 6, so it could be 6 times -7, or it could be 7 times -6. But we want the ones that add up to, what number is this right here? It's really a 1, so I need a +1. 7 plus -6. 7 plus -6 is the one that gives us +1. So in this case, it's just going to be n plus 7 and n minus 6. That one was nice. There was no common factor to factor out. All right, and we're done.